All right, here we go, guys. So right up at the top are the two formulas I was telling you about on the front side. Okay. This one is used for arithmetic sequences, and it's on our reference sheet, which means the exam allows you to use the formula, so you don't have to memorize it. And this one here is the geometric sequence, okay? Remember, arithmetics have a common difference, and so there's their difference, whereas geometrics have a common ratio, and so there's their common ratio, okay? Both formulas have a sub 1, which you have to remember is the first term, because remember 1 with a subscript would make that the first term. And here this is also a first term, okay? Notice the difference in arithmetic, which is an adding sequence. They have that plus sign in there, where geometrics are a multiplying sequence, and that's why this is being multiplied in there. Okay? Both sequences have an n minus 1. All right, here though is a little bit different, where their n minus 1 is here. Okay, remember geometrics follow an exponential modeling, whereas arithmetics are a linear. So you guys can see the difference there in your formulas. Okay, n is the number of terms in both of them. Okay, and I like to refer to a sub n as being any term. Okay, so for instance, if I was looking for the 50th term, that would be a sub 50. If I was looking for the 100th term, that would be a sub 100. So n can be anything it wants to be. Okay. All right, so hopefully that helps and explain the formulas, and we'll go down and see if we can plug in the information that we get in our problems. Okay, so E, which just seems like a continuation from the problem on the front. Okay. So it says, using the explicit formula above, write a rule for the nth term of an arithmetic sequence. Okay, so we're looking for arithmetic, where a sub 1 equals 5 and has a common difference of 3. Okay, so in an arithmetic sequence, we have some variables. We have a sub n, a sub 1, n, and d. They told us the common difference is 3, so that one's an easy one. They also told us a sub 1 is 5, so that's easy. And they want us to write a rule for the nth term. And anytime they want us to write a rule for the nth term, anything with n in it stays n. So see how that has an n in it? So this is going to stay a sub n. This is n, so this is going to also stay n. All right, and so we're going to have a sub n equals our first term, which is 5, plus n minus 1 times our common difference of 3. And that's actually a fine rule. However, it's not completely simplified because of the parentheses in the formula. So what we can do is we can go ahead and distribute. Okay. However, the way the formula is written is that what you're multiplying and distributing is written behind the n minus 1. So you have to kind of think of distributing this way. And so we would get 3n minus 3. And there's one more thing we can do and clean up those two terms there. So we can put 3n first, and then 5 minus 3 would be a positive 2. And there's our formula. And you guys can see that it looks like a linear equation with like a slope and a y-intercept. And your slope is actually your common difference of 3. Okay? And this would be kind of like your y-intercept. Okay. All right, part F says, using the rule from part E, determine a of 160 or a sub 160. Remember that? We did that on the front, but we had to think that like 159 times we were adding 3 and then add that sum to our first term. Well, if we follow the formula, this might become a little bit easier. Okay, so again, we have our variables, and some of them aren't changing, right? Okay, so for instance, actually, we already have the rule, so we don't have to even do this. We could just take our formula, okay, and notice the 160 is where the n would be. And so we're doing a sub 160. Notice we just replaced n with 160, so we're going to replace n here with 160. And all we have to do is type that in. 3 times 160 plus 2. Okay. And 3 times 160 plus 2 is 482. And if you remember, our answer on the front side was 482. So you can see that the formula might be a little bit easier. However, you have to come up with the formula first and then just plug into it. Okay. All right, let's see what they have for number 4. Okay, it says given a sub 1 equals 2, and the common ratio is 3. So notice how they said ratio? That makes this geometric. Oops. So we have to make sure that we are looking at the geometric formula if we have to use it here. So they said find the first 4 terms. First one's done for us. Remember that we are multiplying by 3 here. So if we take 2 and we multiply it by 3, we would get 6 for our second term. Our third term, if we multiply 6 by 3, we would get 18. And if we take 18 and we multiply it by 3, we get 54. Part B, it says, is there a faster way to get to a sub 4 instead of listing all the terms out? So what we have to do is we multiply by 3 here once. To get there, we multiply by 3 for a second time, and then we multiply by 3 here a third time. Okay, so since we are multiplying by 3 times, that actually ends up being 3 raised to the third, right? That means 3 times 3 times 3, okay, which is 27. However, we are taking our first term, which is 2, and multiplying it by 27, which ends up being 54. And you can see that that was our fourth term, okay? But instead of thinking like that, there's a formula up above that allows us to just plug in to find that as well, okay? Again, formulas are supposed to be shortcuts. Part C says, in order to find a specific term or output in a geometric sequence, what are the 2 pieces of information needed? Same as what we had on the front. We need to know our first term, which is known as our a sub 1. And we need to know what we're multiplying by, which is known as our common ratio. And that's represented by the letter R. Okay, so now they want us to find a sub 20. And they didn't say to use the formula. We actually haven't even made a formula yet. So let's see if we can do this the old way. We would be multiplying by 3 19 times, which is 3 raised to the 19th, which is a very large number. You can see once we put all the commas in, okay, we end up with a super large number, all right? But it makes sense. If you remember that we said that geometric sequences are exponential, they grow fast. You can see how fast this one is growing. All right, so now we have to take our first term and multiply it by that. So now it's even going to get even bigger. And that is our 20th term. Pretty fancy, huh? All right, let's go ahead and see. A lot of people don't like geometric because they think they made a mistake when they end up with these giant numbers. But again, you just have to remember geometrics are exponential. Exponential growth are going to grow pretty darn fast. So in part E, it says using the explicit formula above, write a rule for the nth term of the sequence. Okay, when they gave us our first term and our common ratio. So remember our variables that are up in that sequence for geometric. We have a sub n. We have a sub 1, r, and n. And they told us our first term, which is a sub 1, which is 2, and our common ratio, which is r, which is 3. And when you write a rule for the nth term, anything with n in it stays n. And so all we have to do is now go plug that in. Okay, so we're going to have a sub n equals 2 in parentheses is 3 raised to the n minus 1. And there's our rule. Okay, so the rule is very easy, especially since the formula is given to you. Part F says using the rule from part E, determine a sub 20. So what you have to realize is that this 20 is in that n spot. And so we're just replacing n with 20. So we're going to say a sub 20 equals 2 times 3 raised to the 20 minus 1. And really we just have to plug that into our calculator. If you have the older black calculator, you might want to change that 20 minus 1 to a 19, or you'll have to remember to use parentheses around the 20 minus 1. Okay? But then when you type it in, you should end up with the same exact number that we got up in Part D. But in Part D, we had to kind of think about what you're doing, okay? And a lot of people have trouble with remembering what we're doing. We're multiplying by 3 19 times to find the 20th term, okay? Whereas the formula allows us to just not have to think and just plug in to find it. All right, so a little bit of a shortcut. All right, I will see you guys on day 2 notes.